Hello my dear friends. Welcome to my channel. Today let us study how to detect a cycle in a directed graph. So first of all, we should understand what do we mean by a cycle. So basically, a cycle means that is when we are starting from some point and reaching to that point after some time, after traveling some distance. It means there will be one cycle along the way we are traveling. So let us take this example. In this example, we are starting from 1 and moving to 2, and from 2 we are going to 3, and from 3 we are going to 1. So it means there is a cycle between 1 with respect to 1 and coming to 1 again. So there will be a cycle in between this way, so that we are reaching at that point. This basically means a cycle is. And let's see what does a directed means. And a directed means is that means from one node we can go to other node in this way. It means that it is directed to this. It is not, we cannot come from 2 back to 1. So we can only move from 1 to 2. So let us understand what do we mean by a directed. A directed means is that from particular node we can move to 2 in this direction. Means is that there is no way from 2 back to 1 from this, so that it means that we cannot move from 2 to 1 in this way. There can be another way from which we can move from 2 to 1, but we cannot move to 2 to 1 in this way. There is only a one way from moving from 1 to 2. Similarly to this, we can move from 2 to 3. Cannot move from 3 to 2 from this way. There will be another way, may or may not, but from this way we cannot move. Similar to this. So basically this we mean by a directed, and we understand the basic terminology. What does a cyclic, what does directed mean? So now let us see the example how to detect a cycle in a directed graph. So let us see in this example whether there is a cycle in this graph or not. So we will see in this algorithm. Basically, what we are doing. I will tell you that in this algorithm, from each node, this one, from each node we are doing a DFS search and checking whether with respect to this node there is a cycle exist or not. If not, it will return false. Basically, we are doing a DFS search. So before seeing the further video, please understand what does a DFS search is. So you will get more clarity in this algorithm. So what we are doing is that we are doing a DFS search from each node and checking whether there is a node whether there is a cycle exists or not with respect to this node. Okay, if it does not exist a cycle, it will return false. Then we will check again other node, that is 1. Then we will see with respect to this node we will do a DFS search and check whether there exists a cycle or not with respect to this node. And in this example there is no such cycle, so it is coming to here. So there is not any cycle. Then it will return false. Then we will go to 2 and check whether there is a cycle exists or not. So in our example, there is a cycle exists with respect to 2. So it will return true, and our function also return true, and we will come out of our function and print that there exists a cycle in our directed graph. So basically, so let me tell you the algorithm we will be implementing, we will be using for this to detect a cycle in a directed graph. So basically we are taking two boolean array, named it as boolean visited, which is of equal to the length of the adjacent list. 1, 2, 3, 4, 5. Initially all the position in our array is marked it as false, and it is that array which does not change its value when we will traverse through our list from each nodes. That is, if we traverse from 3, 1, 2, the value remains same. What I mean to say is that let me draw another boolean array, boolean current. Okay, it will be also equal to the length of our adjacent list. So by the way, if you don't know the adjacent list how to draw it, you can see more videos on YouTube. There will be plenty of videos. So let me tell. So what I mean to say is that in this array, all the elements initially in this array is false, in this boolean array, and in this array also all the elements are false. Okay, so basically in this, when we travel from this array, when we do DFS search from this node, then this boolean array will be recreated itself, will be created, okay? And this will remain same. When we do DFS search, when it will be marked it as true when we will visit a particular node, and there also we will mark it as true when we visit a particular node. So when we travel from 3, when we do DFS search from 3, we will mark all the points we are visiting true here, true here, true here, what all the points we are visiting in DFS search. If we will not found any cycle while doing DFS search with respect to 3, then we will do DFS search with respect to 1 again. So in that part it will remain same for this one also, for this one also, but this boolean array will be recreated again. So all the elements which are marked true in this element will not be there, and it will be recreated again. Then again our current boolean array will be all the element in that also false, and it will regenerate itself again and again when we visit each node separately. Okay, so let me explain this example how we see there is a cycle in this graph. So let me tell you how to see. First of all, let me draw an adjacent list. What will be adjacent list of this graph? So here 1, is there any neighbor of 1? By the way, the neighbor we mean is that from where are the position we can reach to. From 1 we cannot reach to, we cannot go to 3, we cannot go to 2. So there is no neighbors in this, neighbor of 1. So from 1 we cannot go to anywhere. Is there any neighbor of 2? Yes, from 2 we can go to 1. So 1 is the neighbor. From 2 we can also go to 3. From 2 we can also go to 4. So from 2 we cannot go anywhere else. So 2, 3, 1, 3, 4 are the neighbors of 2. So we will check, is there any neighbors of 3 exist in our graph? Yes, 3, from 3 we can go to 1. So 1 is a neighbor of 3. So if there exists any neighbor of 4, yes, from 4 we can go to 5. Is there any other neighbor of 4? No, we cannot go to anywhere from 4. So next we will see, is there any neighbor of 5? Yes, from 5 we can go to 2. So this is our adjacency list. So now let's traverse this graph from each node. That means do DFS search from this node, from each node, and check whether there exists a cycle or not. So we can randomly choose any node to do a DFS search and check whether there is a cycle with respect to that node or not. So I am going from this node. I'm checking from this node. So our two array will be there. This will be a global array visited. We will name it as visited. This will be a boolean. We can name it as anything. It solely depends on us what we are naming it as, and I am naming it another array current. It can be also named it as anything 4 5, and initially all the all elements in array are false by default. I am not marking it false, even otherwise it will be very hodgepodge. So all the elements initially are false. We will return true when there is a when we will visit any element in this array twice. When it is already marked true when we traverse and again it will come to here, then it means there will be a cycle. So let me tell you the algorithm, then we will understand better. So let us start from 3. So from 3 we will do DFS search. So we will mark it as true here. Then we will see whether there is any neighbor of 1 3. Yes, there is a neighbor of 3 1. Does 3 1 visited in this array? It is marked as true? No. So we will do again what is true. This is nothing else. I am just explaining this one. So it is not marked as true. So from 1, then we will see does there is any neighbor of 1? No, there is no neighbor of 1. So it will backtrack. This is what happened in a DFS search. So again, then we will see is there any neighbor of 3 other than this one is already visited? No, there is no other neighbor of 3. So we will come out of that DFS search function and return false, that we do not get any cycle in this with respect to this node. So again, now we will do DFS search with respect to 1. Before doing DFS search with respect to 1, we will see that is this node is visited, is this node marked it as true in a visited array? Yes, it is already marked true in visited array. It implies that we will not get any cycle with respect to this point, because we have already visited this in our previous DFS search and already seen that there is no cycle with respect to this DFS, with respect to this node. So we will not do DFS search with respect to this node. That we will do our next we will do our DFS search with respect to this node. We will, before doing DFS search with respect to this node, we will see it whether it is visited in our, whether it is marked as true in our boolean array. Yes, no, it is not marked it as true in our boolean array. So we will do a DFS search with respect to this node. So I have already told that this array will remain constant. This will not change when we traverse different nodes, but this array will be recreated again and again. So this time when we do DFS search with respect to this node, then this array will be created again. So our boolean current array will be 1 2 3 4 5. Initially all the elements in it is marked it as false. When we visit it, we will mark it as true. So this is our main array which does not changes, but this array will be changed again and again, regenerated, and initially all the elements are false when we visit do DFS search with respect to a particular node. Okay, So now we will do DFS with respect to this node, whether we will see 2 is marked as true or here not, it is marked as true, not marked as true, and then we will see whether it is marked as true here or not. It is not marked as true, so we will mark it as true here also. Then we will do, and then we will see, is there any neighbor exists with respect to 2? Yes, there is a neighbor, there are 1. So we will see whether it is marked as true in our visited array. Yes, it is already marked as true in our visited array. And does it is marked as true in our current array? No, it is not marked as true in our current array. We will not mark it as true here because it shows that there is no cycle till now in our graph. So we will see that is there any other neighbor of 2? Yes, 3 is also a neighbor of 2. That is, we can visit 3 from 2. So we will see whether it is marked as true in our visited array. Yes, it is marked as true in our visited array. We will also see that whether 3 is true in our visited array. No, it is not marked as true in our visited array. It implies that there is no cycle till now with respect to 2. So we will see again any other node which is not marked as true. So yes, there is another node which is a neighbor of 2 is 4. We will see whether it is marked as true in our visited array. We will see no, there is no, it is not marked as true in our visited array, so it will move to here. Now, and it is also not marked as true here, so we will also mark it as true in this array also. Then now from 2 to 4. Now from 4 we will see is there any neighbor of 4 in our graph. Yes, there is a neighbor of 4 in our graph is 5. So then we will see whether it is marked as true in our visited array. No, it is not marked as true in our visited array, so we will mark it as true. If it is not marked in our visited array, then also it is necessary that it is also not marked in our current array. So we will mark it as true. If it is here also it is marked true, then there may be a possibility that it will be marked as true here, or may not. If it is marked as true here, but it is also marked as true here, then we will conclude that there will be a cycle in a graph. That's why it is coming back to that point. So where we are at 4, we have marked it as neighbor of 5 marked as true 5. Then we will see that there is any neighbor of 5 exists in our graph. Yes, there is a neighbor of 5 in our graph is 2. So then we will see whether it is marked as true in our graph or not. Yes, it is marked as true in our graph, so true. So then we will see is it is also marked in our current array. Yes, it is also marked in our current array. It implies that there will be a cycle in our graph with respect to a node 2. That's why it is coming back to 2 in our current visited array. That it is coming back to 2. So it implies that there will be a cycle. So yes, there is a cycle in our graph, that is 1 to 2, 2 to 4, 4 to 5, and 5 to 2. And from here only we will return true and come out of the function, and we will print that there is a cycle in our graph. Okay, so now let me tell you the code for this implementation of how to detect a cycle in a directed graph. So let me write the code now. So let me now tell you how the code of this algorithm will work. So first of all, we will make a function detect cycle. There is no parameter in it. Then we will make a 2 boolean array, visited and current. Okay, the length of this array will be the length of our adjacency list. So if you don't know what adjacency list is, you can visit any video in our YouTube, you will find it. So we will make 2 array, then we will loop through each node in our adjacency list. That is this node 1, 2, 3, 4, 5. I am talking about this node in this boolean, in this for loop. So what we will do is that we will visit each node in our. So now let's see how this code is working. Here I is equals to 1. What is next? We are starting from this I equals to 1 and check whether visited 1 is true or not. Here our visited array, it is not marked as true. Then we will visit it, then we will go to detect cycle util function. Here we will pass I1. Here I is equal to 1. Visited array, boolean visited array, current boolean visited array. This one. Current array, current boolean array, visited boolean array. Here is our function detect cycle util, which we have called here. So v is currently our one boolean visited and current array is this one. So we are taking this example while implementing this code. So from 1 we'll mark it as visited v1 true and current also true. So here are two arrays, true, true. Now we will see that these are for each loop. Then we will see does there exist any neighbor of 1 in our adjacency list. Here there is no neighbor of 1 exist. So what will happen in this case is that we will come out of this for loop, our for loop and here's, and marked current v. What is v in our case is 1. Current 1 equal to false. It is true, then we will mark it as false and we will return false. So here it will come and mark it as false. So then this if loop, if statement will not work, we will come out of this. Then our I will increment, I will become 2, and then we will check whether visited 2 is true or not. Here is visited 2 true or not. Yes, no, it is not true. Then it will move inside this detect cycle util I equal to 2 and visited and current array. What is the position of our visited and current array is that when visited there is only one element which is marked true, and in current array there is no element which is marked as true. That means all the element it is marked as false. Then we can simply rewrite this again so that there is no confusion. We'll cancel it and we will mark it as, we will write it again. I am writing this again because so that you will not confuse while understanding this. So now we will do DFS search with respect to 2. Where is 2? Where is 2? So in this function we will pass 2 and visited array, current array. This one our visited array and this one is our current array. So in this visited array we will mark visited true, 2 equal to true. So here true and current v is also equal to true. So here true. Then we will see does there is any neighbor of true 2 in our visited adjacency list. Then we will come to our adjacency list. Yes, there exists a neighbor of 2 which is 1, 3 and 4. Okay, now from 2 let this will go to 1. So we will see neighbor of current, let us neighbor equal to 1. There are 3 neighbors of 2, 1, 3 and 4. So first consider neighbor as 1. So we will check whether boolean array current has 1 marked as true. No, it is not marked as true, so it will not run. If statement will not run, then it will go to else if, and then see whether in a visited boolean array 1 is marked as true. Yes, marked as true. Yes, it is marked as true, means which it is here false. So means this will also not run. Else if we will come out of it. Else if this else if will not run, then basically there is one more. This is else if and this for loop. Then we will go to next time. Then we will see next neighbor of our element 2. So what are the next neighbor of element 2 is 3. Then we will see whether it is marked as true in our current array, boolean array. We'll see no, it is not marked, so this if statement will not run. Then we will see in our else if statement whether visited 3 is marked as true or false. It is marked as false, so what we will do is that then false, it means we will pass it is not function, so it will true, means this else if loop will run. So we will call detect cycle function, and in this we will pass it as neighbor, visited array and current array. What is the current neighbor we are having here is 3, so we will pass 3 here. So this is a recursive function, it will go to 3, that is here from 2, what we have done 2 to 5 stars go to 1, then it will backtrack it from 2 to 3. Now we are here, so now we will 3. Now it will check what are all the neighbors of 3 in our graph. So in this we see that there is only one neighbor of 3, that is 1. So from 3 it will go from, then we will check whether it is marked 2 in our current array. Then here the result is that it is not marked as true, so this if statement will not run. Now in this else statement we will see that whether 1 is marked true or false in a visited boolean array. So in a boolean visited array 1 is marked it as true, means false, so this else if statement will also not run. Then it will go to again and see whether there is a for loop will run again. Then it will again see whether there is any neighbor of 3 in our list. Then there is no neighbor of 3. Then what will happen, that it will come out of the array and mark current v as false. What is our current v? Current v is our true, so we will mark 2. So what is our current v is 3. Oh, okay, I have forgot to mark 3 here, so mark it as true because we are visiting the 3. So I will mark this 3 true here also, true here also. So what is our current v is 3, so we will mark it as false, so it will become false. Then this function will return false, from which means is that it will return false from where it is coming from, who has called this function, this. So it will return false to 2. Okay, then it is basically doing a backtracking. Then now from 2 also the for loop will end and will mark current v2 also as false, here also as false. Then it will return false. Then 2 is returning false to which function? 2 is returning false to this function. No. Then it will also will mark, we will not mark 2 as false because this for loop is not end till now. Now it will say there is any more at the, that we have visited 1 and 3, and then now we will see that is there any more neighbor left in with respect to 2. Yes, one more neighbor is left with respect to 2 is 4. Then it will visit the 4. From here it first has visited here, then there is no more node, then it will backtrack, and from here it visited here, then from here it will backtrack, then from here it will visit 4. And then we will see that current 4 is marked as true, it is marked as true. No, it is not marked as true. Then we'll see that visited in our visited boolean array whether 4 is marked as true or false. It is marked as false, means this else if loop will run, and in boolean cycle this is a boolean variable which will be having a true or false value. Then we will recursively call this function with neighbor equal to 4. Then we will call here is 4. Then we will mark visited 4 as true here, and current v also as true here. Then we will check what are all the neighbors of 4 in our adjacency list. So the 4 neighbors of 4s are only 5. Okay, then we will see whether it is marked true in our current visited array. What our neighbor is 5, so it is not marked as true, so this if statement will not run. Then now else if statement will run and check whether 5 is marked true or false in a visited array. So it is marked false, so this else if statement will run, and we will call this function detect cycle util with neighbor equal to 5 and visited in current array. Then now this int v equal to 5, that means now we have called this function and marked. Now we will mark v as visited v5 as true and current visited also as true. Now we will check what are all the neighbors of 5. So the neighbors of 5 is 2 only, that is this one. So then we check whether current neighbor is 2, current 2 is true or not. Yes, it is true. That means we have found the cycle with respect to 2. So it will return true. So this function will return true to this function because 5 has called this function. Now this function will return to this one because 4 has called this function, and this will return the function this function because 4 has called to true, and who has called this function? Here the function 2 is called, so it will return true. Then this if statement will run and it will return true, will come out of this function and return true and print cycle exist. Okay, thank you for watching this tutorial patiently. If you will not understand anything, you can comment in my channel. I will personally answer to all the queries, and please see this video again and again until you understand what the basic algorithm tells about. Thank you.